Good morning. This is Public Lecture Review 2. As some of you know, there was a lecture given over blue jeans this past Thursday. There were two guest speakers. One of them discussed the life of someone who had just won a Nobel Prize in physics, while the other gave an overview of the physics behind the prize. I'll start by summing up the first part of the talk, as that was all new information since I did not know who this man was before Thursday. But it's really cool. Roger Penrose was one of the individuals who won a Nobel Prize in Physics this year for his work that black holes are predicted by the general theory of relativity. He's done quite a lot from creating his own language of math because he, as a visual learner, had a difficult time following the usual equations that they teach you in school to writing books. He, at one point in his life, met a man named Finkelstein and essentially they swapped research. And he began investigating space-time, but he also kept at it with the math. He studied topology, which is a super cool discipline. It's geometry, but make it stretchy, and developed twisters. Um, he does preferential physics when he explains how black holes are like body bags, but then back to math when he invents negative dimensions. He also looks at is space continuous or discrete, which honestly is a question I didn't know I even had until now. In terms of the actual physics being discovered with the Nobel Prize, we need some background. First, apparently astronomers weren't always the biggest fans of the concept of black holes. They were first theorized by Laplace and Michel, but then we have individuals like Einstein and Schwarzschild. Einstein's theory of general relativity, like the actual equation, is very confusing, but it seems cool, and Schwarzschild radius seems to look at the radius of the event horizon of a black hole, which is surprisingly large. The speaker then went on to discuss how there is a supermassive black hole at the center of our galaxy, but we can't really be sure enough to call it that yet, not officially. But whatever it is, it's in the center of the constellation we call Sagittarius. And the way it was found was knowing that the closer the stars were, the faster they were moving in elliptical orbits. So astronomers tracked the star positions super accurately, beginning with speckle imaging, which is meant to remove the twinkling effect of the stars, which is really cool. As I didn't think that would mess up observations, but apparently it does. But then they switched to adaptive optics, which is where a deformable mirror removes the twinkling effect. So it does exactly what speckle imaging does, but better. So you get more accurate results. And they found something there which earned them the Nobel Prize. The lecturer also mentioned white holes, but I'm pretty sure the general consensus is that they don't exist. Or they're very unlikely to exist. But it was an interesting diagram with the parallel universe on one side and our universe on the other, and they were connected by black holes and the white holes. It was cool. Those are the main points of this lecture. Pretty much all of that information was new to me, but Roger Penrose's work in mathematics really stuck out to me. I recently added a math minor, and so hearing about his new language seemed really cool and something I kind of wanted to investigate. Um, so I'm curious to see what else he's done, because that seems a little similar to graph theory, which is cool. I did go and look up this language, but I'm not really able to find much, mostly because there is a program that the researchers at Carnegie Mellon developed, and they named it Penrose, so that's kind of like most of the search history, search results, sorry. And they named it Penrose because it shows a mathematical way to explain problems, which is exactly what Penrose does. So I think they named it as kind of an homage to him, even though he's still alive. Um, Overall, this was a very interesting lecture, and if you haven't watched it, I do recommend you give it a shot. Thank you for listening.